Thank you for being here. I will talk about unlocking the main threads and improving your application performance by solving some common problems. And I will share some tricks that helped us immensely over the years. And let me explain who am I and why I think I could be eligible to explain some of the stuff. I have like 12 years of experience. I'm a stuff Android developer, delivery hero. And a fun fact, like 10 years ago, I was part of a group that wrote a book in Turkish, and I was responsible for performance. Back in time, I was also working on similar topics, and then 10 years later, it's still the topic that I am patiently excited about. And I will do a small retro about what I suggested 10 years ago versus what we have now. And I work on a logistic part of our company. So we are a food delivery company. We're delivering over 70 countries, and every day millions of orders are delivered by using our application. So that means every seconds count. And even if a slow application startup, it takes more than 1 second, that means millions of seconds or lost. Or if we have a problem about showing the address to the rider, means that you will get your orders slower. I hope you used one of those brands back in time, and if you had bad experiences, you can share with me later. We might cause them. But there are multiple reasons why there might be performance issues because the production is really wild. The battery level could affect the performance. Even the temperature could affect the performance. And at the moment, we support minimum SDK 23, means that 9 years of Android operating system. And if you consider that like devices which released 10 years ago got one release of one update, one operating system update, means that 10 years of devices, so they will get older, they will get slower, and they will probably overheat and run slower. And at the moment, with the API 23, we have more than 5,000 riders daily delivering food and earning their money. Means that even if we like to increase our minimum SDK, we need to find a solution to that 5,000 people, maybe give discounts to buy a phone. So it's not something that we can do willingly for the business. There are some countries that we are trying to push forward, but it's not fair for everyone to push those devices. And this is a real example. And sorry, it's like too jumpy, but those people are out there using our application to earn money or find something and complete a task. And usually they don't be gentle to our application. They need to get the orders fast. They need to find what is the next task to do. They need to record a video. They need to watch a YouTube video or something. But responsiveness is really important for every user. And it's not that how we test or how we develop our devices. We're probably like tapping very slowly and enjoying it, and your QA people might enjoy like a very calm, climate controlled environment to use the device. But in reality, people use the application on the go, on the bike, on the car, or like we never control those environments. There are different states and levels of the junkiness and the performance problem. And not all of them are equal because some of the things we can live with it. Like slow rendering. It's not great to have a slow rendering, but what its definition is any main thread operation that blocks frame rendering more than 60 milliseconds to 700 milliseconds. That can cause slow and laggy scroll, janky animations, and drop frame rates. You probably notice here and there when you have an heavy operation going on that the animation might stutter, but this is something that we can live on. And this is probably most of Android users are used to. But what is worse is frozen frame. Means that there was more than 700 milliseconds of delay to finish the operation, which caused completely missing multiple frames and probably showed a black screen to the user while doing the operation. That can happen while application startup or a navigation operation. You can also trigger those events in different timeline, but this is the most we saw. And there are different reasons why it's happening, like dependency injection and other problems. But the worst of all, infamous ANR, application not responding, means that we, as an application developer, had an intention to do some logic that took like more than 5 seconds. That means it prevented us to handle user input. users are not able to interact with the application, and operating system is not happy about this process. So if it's a foreground application, operating system kills it and shows an application not responding dialog. But if it's a background operation, means that operating system will kill it silently. User will not even see it, but if you're playing a music or doing a navigation or tracking a gym event, that means your application and experience will be broken. But why it's happening? Because, as you know, there are tens of thousands of Android devices, and not all of them are high-end, and we have limited resources. Even with the good intentions, even with the latest software updates, every year Google update the ART runtime to be more faster. They have profiles, they have lots of tools to help us, but we still have cheap devices. In our metrics, 25, like in some countries, 25% of the devices are low-end devices, and this low-end device is what we created ourselves, like devices with less than 4 CPUs, devices with less than 2 GB RAM. But this means that those devices have worse performance over other riders. And to be fair to everyone, we would like to create equal user experience to all of them. And this is what bad look like on a systrace. There is a frame operation going on, and it took more than 180 milliseconds on my Pixel 7. It's a almost high-end device with the recent things, and this is a basic, simple application which just tries to draw one frame, which will be the slow rendering metric. And this is how it's supposed to look like. Every frame and every main thread operation is supposed to finish under 60 milliseconds, leave some space for other operations, and keep the main thread loop handler idle as much as possible to allow rest of the application to continue working. But how we are going to achieve this one, and what could happen if we don't do it? So slow rendering is a user experience problem. Frozen frame is also as well, but means that users will interact your application more frustrated. They will try to do operations multiple times, even if you have throttled button, even if you have other solutions. They might find those edge cases you don't want to have, and they might crash your application. Especially the foreground services are very delicate in this one, because your foreground service needs to start under 5 seconds and show a foreground notification to the user. If that doesn't happen, operating system kills your whole application, not just the service. And we are experiencing this one a lot after a process restart of the application or after certain cases, because users might change their application, go to the different one, like use Google Maps, listen to music, take a photo, and do other operations to keep the device under load and prevent your application to use the available resources. But since you're here, is there a magic solution that I will share? There are some stuff that I would like to mention. First of all, releasing the memory pressure. It's the crucial step of fixing performance problem, because when your application doesn't have enough resource to operate in, especially in the RAM, it will try to run the garbage collection more. I will talk about this one in detail, but also the other important thing, rendering first frame as quick as possible, but also making sure that rest of the frames are also rendered in the same, in reasonable time. And the last one is draining the main thread, making sure that none of the operations on the main thread are blocking your user experience. An application needs to have some memory to be able to operate. So as I mentioned, so in some countries we have 25% low-end devices. It means that less than 2 GB of RAM. And if they are also using Google Maps and taking pictures, that leaves us very limited resources, including the operating system itself. That's why we need to be cautious about allocating the memory and use as much as possible. But even in the best case, even if we have limited usage, with a small leak can impact our application memory consumption over time. And in this example, you can see that there are lots of garbage collection operations happening. All of those uh, immediate decreases are garbage collection trying its best to gain some resources back. But blue is the Java one, means that there is like a leak going on and it keep increasing. It's not a single leak, but it's continually prevent garbage collection to release those resources. And at the end of it, you probably get out of memory exception. And I could say that out of memory exception in this case is the best case. I, I wish that we get and we reach the out of memory exception faster, because what happens is right before the out of memory exception, if your user is using the app, it will get sluggish, it will get slower, and they will try to use more and more. And at the end of that frustration, it will crash. So it's not just that our application is crashing, but it's the journey that we put in the user, and they experience that it is not a quality application, it's not optimized application. And right before that, and when your application runs long, you likely to hit this kind of problem. Our application has average 8-hour usage per day, because those people are delivering orders, working, and earning their life, means that that application stays alive long, and any leak can impact their work life immensely. So we're trying to avoid that one. There are tools that we can use, but I hope everyone. Is it visible? Yeah, I hope that the Android community is already informed about leak, but to repeat it, any references to short-living things like activity, fragment, or view should be kept in their life cycle, should be kept in their scope. And if they are used and referenced in a bigger lifecycle scope, a bigger scoped object like application, it needs to be cleared. We cannot leave any reference to the listeners or runnables. Things that we need to clear our listeners every time we are closing an activity, every time we are closing a fragment. This is very critical, especially for the libraries, because last year we spent so much time with the libraries that we are using, especially the map libraries and a couple of other providers. And the amount of leaks that we found and reported and they fixed was incredible, because they are also very expensive tools. Every time someone add a new feature on top of already existing framework, they probably are going to create those kind of possibilities to leak memory. And at the moment, it's also our responsibility to find those issues and fix it. Otherwise, they might sink our ship. We have tools to fix those. The best tool that we have at the moment is Leak Canary, that can find the leaks at the runtime, give you a heap dump, and show you the reference tree of which class is holding and which reference and why might it is leaking. So using that reference tree, you can find which object was held in a place where it shouldn't be held. There is also strict mode, which can give you the multiple activity usages and some other features. There's one thing from Leak Canary which is not advertised well enough, probably because it's using lots of reflection and dark magic inside it. There's something called Leak Canary Plumper. It has solutions and fixes to avoid some known bugs, known leaks. There are operating system leaks, there are framework leaks, and some of the OEM devices like Samsung or Oppo might have their own solution. And this Leak Canary Plumper finds those classes and try to avoid those leaks as much as possible. And one example is, for years, Samsung Clipboard had a leak if you use it with the activity context. They were creating the Clipboard instance and holding on this activity. They designed that class to be used with context, but probably they had application in mind and never intended anyone to use it activity, and it took so much time, so much year for them to fix it. But this library helps you to avoid this one at the beginning of the application. It goes and sets the application context to those classes if it's a Samsung device, if it is the certain SDK versions, and help you to avoid maybe unfixable looking leaks that doesn't like that's not our that's not caused by your application. But I also mentioned about the strict mode, which I highly like it. Probably if you add and enable all of them in your application, you will end up lots of noise in your logcat. But those noise are trying to tell you something. Like that means there are I/O operations, there are multiple instances, there might be leaking window context. One thing that you can do instead of ignoring them, collecting them. And we are doing this kind of listener-based collection in our debug builds and our dog fooding application to be able to get them and prioritize them, because the more you collect, then the more evidence you will have, like how many people and how many use cases are hitting those edge cases. And by one, you can fix and avoid those issues. This also brings the topic of uh, how we are going to fix it. If we have I/O operations on main thread, you're probably going to use a thread solution, a threading solution. Now we have multiple solutions, RxJava to coroutine, or the deprecated async task from the old days, but they help us to parse our JSON objects, do encryptions, and avoid running any heavy operations on the main thread. Network operations, for example, can go in the I/O dispatcher, means that while we're waiting for network to respond, CPU can stay idle and start handling other operations in the same thread. And one good thing about the coroutine, when you make a function suspended, you're already declaring that this function is going to do a suspension and handle the work whenever it's needed. The key to achieve this one is doing those thread switches or dispatcher switches low as possible to make the usage safe for everyone else. In this example, this repository is doing a network operation in an I/O thread. So whenever I call, just because it's a suspend function, I will have a trust to think that this function will do the necessary dispatcher switch. So as a consumer of this API, none of your clients or none of your developer friends shouldn't care about which dispatcher they need to use, because if everything is the main safe, if I can call it from everywhere like this, that will give you a safety net while you're developing the application. Plus, no one will make a mistake to call this one on a wrong dispatcher. But yeah, I suggested, and everyone suggested, using different thread pools and different thread solutions, RxJava, coroutine. But they're also allocating lots of memory. Every thread that has been created are using 1 to 3 megabyte memory, and allocating and creating a thread is also doing some runtime operations, which is costly. But the suggestion is using thread pool, so everyone else did it. Lots of frameworks and libraries we are using have their own thread pools. Some of them has like maybe 1 or 2 threads, some of them has 4, 8, or 10 or 60. And if you have those frameworks or SDKs in your application, means that your application's thread usage is very high. It's not a huge problem if you consider that they also kill the thread when they're done, but means that the moment you need it, there won't be an idle thread in their thread pool, and they will create it again. So it's a kind of unnecessary task, which they might also configure in a way that they keep the threads idle and use the memory. But what we can use is share our thread pools among those SDKs. All of those good intentionally written libraries are plug and play. They expect you to start using them, but they also have really nice APIs to be able to set executors, dispatchers, and they create those APIs so we can control which kind of thread pool they have. And in our application, what we prefer to do is, since we don't have much control about the coroutine dispatchers, we got the coroutine dispatcher and convert them to thread executors. We convert them to schedulers, and we convert them to executor service to give different places. RxJava gets a scheduler, OK HTTP gets a executor service, and the coil requires an executor. And Work Manager recently started allowing you to directly pass the dispatcher to be able to control which dispatcher you would like to use. And that helped us to reduce the number of thread counts from 180 to 130 during a heavy operation. So it didn't immediately create an impact. So it didn't solve most of the ANRs, it didn't solve, but it created room for us to work on it. It reduced the number of out-of-memory issues, and now we have much more freedom about adding new features. We didn't go and edit and use all same coroutine dispatcher for everywhere, because the other libraries, while we investigate and read their code, they're usually creating whenever then they need it, and they don't keep the some of them don't keep the idle threads alive and destroy when they don't operate. So we said that, hey, that's a good trade-off for avoiding any possible thread starvation or any possible priority issues, because at the moment these are the ones who does the IO operations and network operations, and we would like to be in control. But even in the best case, let's say we did most of the things, the code we write is not the code that runs on the device. We write Java, we write Kotlin, we have XMLs, we have other resources, and it's not what is running on the device. There is a runtime. It requires a different instruction set, and usually the code we write, when it's compiled, it's not optimized. There are tools that optimize our code on behalf of us, and there was a really nice talk from Romain guy yesterday, explain what kind of instruction reduction R8 is doing and what kind of memory optimization they can do. And it's nice that we have this tool, but it's only good when we use it. And the thing is, in our example, in our case, we saw 25% improvement by using R8 versus not using it. And if you are using full mode of R8, that also gives extra 5% boost to application startup time and some common operations in your code. There are tricks they're using, like enum optimizations, array optimizations, and avoid any unnecessary task to be effective as possible, or utilize the CPUs that we have. So I highly suggest enable it, and if you have extra rules, you can check if you can remove those rules, but please make sure that you use the optimizations enabled. And in the R8, it's enabled by default, but you can also do your own experiments. If you like to learn what kind of resources there are on behalf, like on top of what Romain guy mentioned yesterday, there are like detailed posts from Jake Wharton as well, where they contributed, and you can also go and look at the source code of those optimizations in the R8, because they also have extensive comments. Since they're doing some black magic about instructions, they need to have full explanation about why they're doing, and there are also tests to verify those. These are all good. We start using the thread pools. We have compiler and an R8 with us, but still there are things that we do to be able to render the first frame, to be able to open our application fast, or to be able to do the navigation between activities fast. And the one thing is, every application, almost every application shows some icon or shows some images. In this case, it was always been suggested to use the PNG up until some time ago, but now WebP is more efficient. WebP uses less memory, and also runtime is optimized to show it more effectively. Memory usage, it provides less memory usage. Also, reading from the I/O will be faster. But that's only one picture, one side of the thing, because we also have vector robots. They're better, they're space efficient, and they're scalable. That means we don't have to have multiple WebP in our application. There will be a single file to manage. And they're supposed to be faster to load. But vector images are complex. Simple ones are really nice. CPU can handle them very well. But I must say that, hey, this guy is doing a heavy lifting over there, and I would like to show you what is carrying. This is the scroll of the source of that guy. So it has lots of curves, it has lots of lines, and CPU needs to do parsing of all of those numbers, all of those floating points, then convert them to float, then do the math operations to where to draw those lines, and all of them happens on main thread by default if when you use paint resource or when you load it from the resources. And we don't have much control about the thread there at the low level. So that means while we are loading those, we need to make sure that we are in the right thread. There are solutions that can help us, but before going there, there is also another important topic of dependency injection. Dependency injection happens when our application starts, when our navigation happens, when our activity starts. But the suggestion is not having any side effects while creating classes. That means that our application's init block shouldn't do any heavy operations. When you have field assignments, they shouldn't do any heavy operations. And we found IO operations while creating file to be able to get the latest value from shared preference, for example. Or there were expensive calculations or expensive calculations and IO operations in the init block of the classes. While you're injecting it, your main thread needs to create those classes on behalf of you. And if you inject the instances of it, there will be slowness. There is this sample that I created. So problems of ANR or the slow render usually doesn't happen by a single class. It's the combination of multiple things and it aggregates. So if most of your classes are doing heavy operations while doing the injection, while doing the navigation, or while user interacting, there will be cases like this. These trap slits are examples, but you can put IO operations, you can put math operations, or loading a resource file like vector, drawable, IShow. And eventually there will be an ANR at the end of it, and your ANR metric and stake trace will show the last one, and while trying to fix the issue, you'll probably consider that, hey, that's a fast operation, it shouldn't happen, there shouldn't be an ANR, but it's the aggregation of everything happening in the application. So we solve those issues by moving some of the heavy lifting operations into background thread. Our examples are OKHTTP creation and encrypted shared preferences creation. In our case, we had 4 different encrypted shared preferences, and they're very expensive to create. Average, they take like 300 milliseconds. If you are creating all of them on the main thread, that's easily 1.2, 1.5 milliseconds just to spend for creation of shared preferences. Even if you parallelize them, since there is only one cipher on the device, they need to wait each other to be able to do the encryption and use the master key on the device. So if you can, avoid having multiple encrypted shared preferences instances and migrate to use one of them. If there are libraries that you don't have full control of, ask them to be able to provide your own instance and take control of the shared preferences if you can. Otherwise, there will be IO operations on the main thread which we need to wait. And the same topic with OKHTTP, they also need to access the cipher or initiate lots of operations on the main thread. And we can avoid them, and we can also check them while doing the injections. We can ask the looper which thread and which looper we have at the moment, and there is also a main looper which we always have access, and we can compare them to see that are we in the main thread. And if we are on the main thread while doing this injection, I can do an exception, I can do a log, and this is our debug log, by the way. We don't, at the moment, if anyone mistakenly injects OKHTTP without using any lazy or provider, we throw an exception and prevent them to do this mistake and create any performance problem. Well, what you can do is using Dagger lazy and inject those instances lazy. There are APIs to provide OKHTTP instance to retrofit lazily in a Lambda, and there are also other operations like other APIs that will help you. Like I said, most of the time default APIs constructors are there to plug and play, but always investigate, hey, is there a way to pass an executor? Is there a way to pass this one lazily? In the real example, in the real world, we had these images. This is also a nice one. Our designer was very happy. They did like design review. Everyone was happy, and they were excited that we are going to have a nice user experience. And we used composable image to show it. There's nothing fancy going on. But on the Pixel 7, with the release application, with R8, it takes almost 80 milliseconds to just finish this icon, this image. Why? It is very big, it's very long. There are lots of curves, there are lots of lines. It's supposed to be a web piece, supposed to be illustration, but the designer team draws this on a application which they also export as a vector, and we use it. And this we are not part of this process. We just use the end result. So in this case, talk to your designer, bribe if you can, or teach them what you want and show proof that it is actually slow. Do your systrace and show them. At the moment, we are migrating away from some of those expensive icons because that wasn't definitely an icon. It was an illustration, and they're migrating all of those as an illustration in a WebP. And besides the no connection, we are pushing more and more to download those images so we can use some asynchronous loading mechanism. But that asynchronous loading mechanism also can help us with these big objects. Coil, Glide, or whatever, like whichever image loading library you're using, they have this resource support. You can load on-device resources with those image loading libraries, with the in-memory cache, and with all of the benefit. This will allow you to finish your first frame to execute quickly, and it will update the icon whenever the loading happens in the background thread you specified. And we had almost 12 icons on the main page. By doing this one, we reduced the frozen frame a lot. In the optimization part, Play Store also helps you a lot, but you need to use the report fully drawn API that lets operating system and the Play Store that your application is ready to use. And they use this one to create profiles, performance profiles. When your application is updated, Play Store start collecting those profiles and also share with other users so they can run those profiles and optimize the application and get ready. But there's a caveat for this one. Why? It takes some couple of days. It's not fast. We don't have any control. And it depends on the other people to use our application and the distribution of the Play Store. What we can control is the baseline profiles. I highly suggest using baseline profile in our experiment. It gives like 30% improvement for new install and for update. And in our case, we do updates weekly. Means that we have over 50 releases per year. If we include the hotfixes, maybe more for some brands. It is very high likely that a writer will update the application and hit those initial compilation time. If they hit once a week, this is going to ruin our metric. That's why we introduce baseline profile, and that reduced the frozen frame and the ANR immensely. And you can do your own benchmark before going to the production. And I think the first one is like could be a bit pain to get started, not a big problem. But afterwards, you can just update like every quarter or every month. You don't need to do full, fresh baseline profile every time. You can still get benefit of this baseline profile on top of what Play Store helping you, because after the installation, Play Store will continue to share those profiles dynamically. You need to measure what's the important part. I may already mention the benchmark profiles, but they run locally and they are not representing the real world data. But for development purposes, you can use Perfetto, you can use systrace. There is now a tracing dependency for Compose, which also add those trays to your systrace. So you can see what Compose is actually doing underneath. And most importantly, you need to collect data from the users, because in your controlled environment, it will be all good, but in the real world, it will be difficult. Measure as much as you can, and always start with the high level first, and then deep down, go to deep down, because you would like to have a systrace that's filled at the first layer, then find out which part of your code, or like application startup or click handling, is taking too much time. There are critical points that we notice while investigating. One of them is Android operating system is very slow to collect ANRs up until Android 14. Previous to Android 14, it took like several seconds. So that means the stack trace that is been reported as ANR is not the actual ANR that happened. After the Android 14, they reduced that stack trace capturing to 10 or 20 milliseconds or something like that. It's best effort. Means when you do investigation, I suggest you to filter for Android 14. That might give you better stack trace to find which class or which logic you have problem in. There are lots of things that you can do, move things in the background, but visible performance is the one side of the coin. Yes, we can move operations in the background like shared preference initialization. But one thing that happened in our example, like in case, we moved all of the encrypted shared preferences in the background, but since they are depending on the cipher, they lock each other, and in the background, one of them waited more than 1 second. Even if we opened the application, we were still waiting to load the data to be able to render something to the user. That effect, moving it to the background, didn't improve our application interactive time. So we had to merge them together. That's why always look outside of the main thread, always look other perspective. And instead of hiding the inefficiencies, look at the root cause and how we can avoid it. I mentioned that I will do a quick retro. So 10 years ago, like I mentioned, I was also working on the performance topic. Topics were different, but in reality, in a sense, they were actually the same thing. And then today, we have composables with if checks to make sure that we are not doing unnecessary increase of view tree. We have list views and view folder. We had the list views and the view folder. Luckily, we now have recycle view, and the lazy column is also becoming a bit more performant. We had memory leaks, and we still have memory leaks. We run things in background with async tags. Nowadays, we have coroutine, RxJava, and a bunch of others. But things still need to be optimized. So, as a developer, we have responsibility to develop our applications for the business, for the product. Also, we have the responsibility to develop something optimized for the devices. People always say that iOS applications are optimized. Yes, could be. The operating system might help, the APIs might help, but we also have those APIs to be able to use resources respectively. Things are just different, but we still need to do some optimizations every day. And this is one of the graphs that we had for application startup to interactive after doing background optimization for OK HTTP, shared preferences, and baseline profile. And I wish you, all of you, to have a graph like that. If you can apply any of the things that you learned from this talk or any of the talk, feel free to share and tag me. I will be very happy. I'm also an Android user. I would like to use performance application. That's why I'm sharing more. But I wish you all like a graph like this, and you can show off your colleagues as well. So if you have questions, I will be around. I don't know if we have time to question, but thank you.